Yes. All right. We're up and running now. 2.5 rates of change, or rates of change, as they call them in Ireland, and particle motion number 1. That kind of is a little bit of foreshadowing right there, right? That there might be a particle motion sequel coming out, and there will be. All right, so there's probably the most, not I would say important, but prevalent application of calculus is the physics application, because again, that was Newton's motivation, describing how motion changes at an instant. But before we do that, we're going to have to learn how to decipher math equations into English sentences so that we can produce results of our answers that get full credit. Okay? So we're going to be talking about the rate of change of a lot of different things before we get specifically to the rate of change of position. All right? So in example 1, here's what we have. The temperature, capital T, in degrees Fahrenheit of a cold yam placed in a hot oven. Now right there, that just kind of evokes images of fall and Thanksgiving and all the good things that come along with it, right? Cold yam in a hot oven is given by a function of little t. So big T, big temperature, is a function of little t, where little t is the time in minutes since the aforementioned yam was placed in the aforementioned hot oven, okay? In a complete sentence with units, translate the practical meaning of this mathematical sentence, really. F of 20 equals 255. Well, here's what I would recommend you do each and every time. Draw a little first quadrant X and Y axis, and on the Y axis, label it as what you're measuring. We're measuring temperature, big T, in degrees Fahrenheit against little t, time, in hours. Okay? So now, when it says F of 20 equals 255, that's basically the instantaneous temperature of the cold yam in the hot oven at that moment, right? So you want to get in the habit of starting your translations, if you will, from math language to English language with the independent variable, right? After all, when we evaluate a function, we start with the independent variable, F of 20. So to do that in English, we start with an adverbial clause that references the moment in time. So here's what you would say. At t equals 20 minutes. In any verbal description or verbal translation, you need to make sure that you have units on your independent and dependent variables. At t equals 20 minutes, comma. At that instant, we're measuring the temperature to be what? 255 degrees Fahrenheit. The units of the function are just the units of the y-axis. So at t equals 20 minutes, comma, the yam's temperature, the temperature belongs to the yam, so I'm not using the passive voice. I'm using the active voice, right? Not the temperature of the yam, but the yam's temperature is 255 degrees Fahrenheit. That's the quote-unquote position of the yam. It's the instantaneous position. Now, part B, it asks, what is the sign of F prime? Well, once you have your little first quadrant diagram here, you could say big T prime, and the units of the derivative, since it's a rate of change of y to a rate of change, or it's the rate of change of y with respect to x, the units of the derivative are always going to be units of y divided by units of x. So you can almost use stoichiometry sometimes if you're not sure what you're supposed to do. If you know that you need to divide to get the proper units, it's probably going to be either an average rate of change problem, where you use the difference quotient, or an instantaneous rate of change problem. So that's the units of temperature, degrees Fahrenheit per hour. So now we can answer that. What is the sign of F prime? It's got to be positive, right? Because assuming that when I say a cold yam placed in the hot oven, relative to each other, the yam's temperature is less than the oven's temperature. And the way ovens and cold yams work is when you put a cold yam into a hot oven, the temperature what? Rises. It increases. It never falls, okay? And it'll approach the temperature of the oven. So if you wanted to think about what the graph would look like, you would have an initial temperature of the yam. The temperature would increase very rapidly in the very beginning until it approached the ultimate temperature of the oven, the oven's temperature. in which case it would still increase but at a decreasing rate because there's less temperature to gain. It can't gain it at the same rate. What type of curve would we have here on this type of problem? Well, it looks kind of like arctangent, and it does have two horizontal asymptotes, but it doesn't really follow the curve of arctangent. This is what we studied in pre-cal. This is logistic, right? Remember the Grinch shutting down Wasselfest, right? This is a logistic curve. This is also how communicable diseases spread through communities. Okay, so anyway, the sign is positive. Positive. The sign of the derivative is positive. Why? Since the yam's temperature is what? Increasing. The yam's, what did you say? The right answer? The wrong answer. Oh, I can barely hear you from over here. Since the yam's temperature is increasing. Okay, it's going up. It's heating up. What are the units of f prime of 20? Well, we've already kind of thought about that. The units of the derivative are the units of y, degrees Fahrenheit, per units of time, which are hour. So degrees Fahrenheit per hour. It's a rate of change of temperature with respect to time. In a complete sentence now, what is the practical meaning of the statement f prime of 20 equals 2? So this is the type of stuff right here that on an application-free response, there's usually one part where it says explain the meaning of what you just found. Okay, and so here's what we're looking for. Just like we start with the independent variable of 20, we start with our introductory adverbial clause that references the moment of time. So we'll say at t equals 20 minutes. You're going to want to start answering these as if you were like an engineer and not like a wordsmith, okay? So don't try to deviate from the script. After 20 uneventful but inspiring minutes, you know, whatever. Don't do that. Just say at t equals 20 minutes. Boom. At that instant.
The units are not per hour. Minutes, right?
Did I put hour? It's minutes. Yeah, minutes. Very good. Very good. I'm going to blame that on tunnel vision. Always nice to have something to blame, isn't it? Thank you for catching that, Colin. You've redeemed yourself today for your careless mistakes on the quiz already. In a complete sentence, then, what's the practical meaning? At t equals 20 minutes, comma. At t equals 20 minutes, comma. 2 is going to have units of degrees Fahrenheit per minute. So that's the rate of change of what? The yam's temperature. Anytime you're taking the derivative, you're talking about the rate of change of whatever you're measuring on the y-axis. And since we're measuring the temperature of the yam on the y-axis, here's what you're going to say. At t equals 20 minutes, the yam's temperature, the yam's temp, is, do you want to say changing? Increasing. These are going to be vector quantities. And if you have a positive rate of change, you want to say increasing by the magnitude rate. And if you have a negative quantity, you want to say it's decreasing by the magnitude's rate. So you want to always say increasing or decreasing. When you say changing, that doesn't really imply the direction. So the yam's temperature is increasing by, or at a rate of, it means the same thing, fewer words, by 2 degrees Fahrenheit per minute. And in this case, because it's a verbal explanation, it's probably best to answer it as units of y, PER, writing it out, units of t, by 2 degrees Fahrenheit per minute. There is a time to put degrees Fahrenheit / minute, and that's our numeric answer. But in a verbal description, you want to go ahead and describe it. So that means that at that instant, if one more minute was to go by and it was going to continue to heat at that rate, the temperature of the yam would be 2 degrees more than what it was a minute ago, okay? But that's not going to be the temperature in the very next instant because at some point the temperature starts decreasing or increasing at a decreasing rate, I should say. So it's only good at that moment. And that's it. At t equals 20 minutes, the yam's temperature is increasing by 2 degrees Fahrenheit per minute. Any questions on that? That was kind of I broke it up into several parts just so we can kind of get all the components in there. But it was all leading up to interpreting this right here. All right, so there you go. Calculus now can be used to describe how a holiday vegetable's temperature is changing at any given moment. Bring that up at Thanksgiving. Be the hero of the dinner. All right, example 2. An ice cream company. Oh, This sounds creepy if you kind of think of it's like the first line of like a novel. An ice cream company knows. What do they know? Why do they know it? An ice cream company knows. What do they know? They know that the cost in dollars to produce Q quarts of cookie dough ice cream. Okay, that makes sense. They're not like knowing intimate parts of my life. They know how to make ice cream and how much it costs. It's due in part to the number of quarts they produce. There's a lot of different variables that go into the cost of making a quart of ice cream, but in its simplest terms, the cost is a direct function of how many quarts they produce, right? Makes sense? So that's why we say C equals F of Q. The cost of producing is a function of the number of quarts. So which one would be your independent variable there, the Q or the C? The Q, right? The Q is your independent variable, and the cost is your dependent variable. I put Q equals Q. I meant to write independent and dependent. So the cost, now you could say, depends on the number of quarts being produced. So let's go ahead and draw our little first quadrant dilly-madally. And I got the cost on the y-axis measured in what? Euros? Dollars, yeah. And the Q is going to be quarts. Okay, the quantity in quarts. Let's go ahead and do this. What would the units of C prime be? Kind of get that up and running. Dollars per quart. That would be the rate of change of the cost as a function of quart. We call that marginal cost. To produce one more quart, it would cost approximately whatever C prime is at any given moment. All right, so let's go ahead and answer the question. If F of 200 equals 70, explain in a full sentence exactly what this means in the context of the problem. So what are the units of 200? Quarts, right? So you could say something like, at the 200 quart production level, right? You could say that. Or you could say, when 200 quarts of ice cream is produced, whatever. Or you could even just say, like I said as an engineer, when Q equals 200 quarts, comma. That's fine too. You're referencing the instant, the moment in time. What are the units of 70? Dollars. At the 200 quart production level, it costs $70 to produce. Now you can, if you're a wordsmith and you're really good at the English language, you can say the exact same thing with units in a slightly better version, right? It costs $70 to make 200 quarts of ice cream. That's another way to say it. But you want to get in the habit of developing this little recipe here. The independent variable is the introductory adverbial clause, referencing the moment in time with units. Good. Letter B, F prime of 200 equals 3. We're going to explain what it means. Now, with notability, we could do this. It's the same moment in time. So I'm just going to come up here and copy that, because that's a lot of writing. Oops, I pasted the wrong way. It's cool you can paste as an image now and it won't erase. At the 200 quart production level, comma, this is F prime. So 3 represents the rate of change of what? Cost, right? It's the rate of change of costs. We're measuring cost on the y-axis. So the cost is what? The cost is $3? The cost is $3 a quart?
$3 extra.
There you go. The cost is, remember, it's the rate of change of the cost. So you always want to say, when you're interpreting a derivative, you want to say the word increasing or decreasing. One of the two. Don't ever leave that out, unless you could say it some other way. Like up here, we could have just said the yam is heating up. Heating up is another way to say its temperature is increasing. So always look to say increasing or decreasing when you're interpreting some derivative. So at the 200 quart production level, the cost is whating? Increasing, because it's a positive number. The cost is increasing by $3 per quart. In microeconomics, they call that the marginal cost. At that production level, at the 200 quart production level, the marginal cost is $3. So you can predict moving forward, if you were to make the 201st quart, it would cost you about an extra $3. That helps you decide if you want to make it or not, right? If you could sell that quart for like $5 and it only is going to cost you $3, you're like, man, that's an extra $2 per quart. I think I'll go ahead and make that, right? Part C, F double prime. What the? F double prime is the rate of change of F prime, yes? So what would the units of F double prime be? Well, let's draw a little picture over here. Now if I measure C prime on the y-axis, now my units are dollars per quart, still measured against the same independent variable of quarts. So the units of C double prime or F double prime would be dollars per quart per quart. It would be like the acceleration of the cost, right? Costs can accelerate. They can accelerate out of control. Dollars per quart per quart. So C double prime is measuring the change in the production or the cost rate, yes? It's measuring the change in the cost rate. So let's go ahead and say then, again, at the 200 quart production level, that's the same. At the 200 quart production level, the rate of change of cost is whating? Increasing or decreasing? Is decreasing by, now decreasing interprets the negative, so now you're going to report the magnitude of that, by $0.1. So I'm going to put an extra zero back there. So $0.1 is a dime, right? Is decreasing by $0.1 per quart, and then PER, quart. Whenever you're listing the derivative in a verbal statement, you want to list it as the units of the function that came before units per units of independent variable. And since the first derivative came before the second derivative, and the first derivative had units of dollars per quart, now in the verbal sentence we're saying that the rate of change of the cost is decreasing by $10 per quart for each and every quart that's produced. Okay? So you can almost say that the costs are increasing at a decreasing rate. What would the curve look like if the costs are increasing at a decreasing rate? It would look something like that, right? Costs are increasing but at a decreasing rate. That's usually what they call economies of scale. Have you heard that term? When you do things in bulk, it's going to cost more initially, but the more you produce, you're offsetting the cost of each one. So costs are still going to go up, but at a less and less rate. So that kind of factors into, your production level. All right. Any question on the ice cream company? Doesn't say anything here about listeria. Thank goodness Bluebell got rid of that problem. Now it's my problem. Trying to control eating so much of that good stuff. Apparently the stuff that's in the store, that's the extra Bluebell, because they eat all they can and they just sell the rest. So, wow. They must eat a lot, more than I do. Example 3. Have you ever been to Brenham and taken the Bluebell tour? That's a good tour. They give you a little sample ice cream at the end. They do give you experimental flavors. Yeah. This one tastes like dog poop. Well, that's we're trying that one out. It's not a big hit. But what do you think, Colin? How'd you like it? No. Okay. Example 3. Now, who is that? There's some people that come up with like gross fart smell, Jelly Belly, right? The Jelly Belly. They make those disgusting flavors of jelly beans, right? And then they put them with the ones inside that taste very good, and it's like it's a crapshoot. One comes out and you're like, ooh, that could be Double Dutch chocolate or Doberman Pinscher poop, right? And you don't know until you eat it. Like, oh, that was definitely Doberman Pinscher poop. I remember last time I tasted it, it tasted like this. Example 3. Let F of t be the amount of rain in inches that has fallen since midnight. Ooh, there's a lot of rain. Well, it could be like fractions of inches. It doesn't say how many inches. Where t is the time in hours since midnight. So midnight is our t equals 0. It's our basis for starting t. In a complete sentence, including units, interpret the following in context of the problem. All right, step 1, let's draw a little picture. We're measuring f of t on this axis. and that's going to be inches of rain. And on this, we're doing T in hours since midnight. So F prime immediately is going to have units of what? Inches per hour. Good. All right. So F of 10 equals 3.1. 10 is the independent variable. What are the units of 10? Inches or hours? Hours. So you could say at T equals 10. That's fine. That's the engineering way. At T equals 10 hours. Or, what else could we say? 10 hour, at T equals 10 hours after midnight, or at 10 a.m. So that's fine if you want to kind of deviate from the engineering script, which are just the facts, right? That's fine. Just make sure that you clearly are stating what's happening. At 10 a.m., 3.1, is that a rate of change, or is that, what are the units? Inches, yeah. So 3.1 inches of rain has, have, or had fallen? Had fallen? Has fallen. Have fallen? Has fallen. 3.1 inches of rain had fallen. Okay. Yeah. So whatever you want to say. Has fallen, had fallen, has, have, had fallen, has, have, had, do, does, did, shall, would, should, would, may, might, must, can, could. Remember all those? No? Y'all never had to memorize those? The helping verbs? No? All right. Letter B. Is that F prime? No, that's what? F inverse. So what happens to the x and y axis when you have an inverse function? They flip. So now F inverse, we've got hours on the y-axis as an independent variable of inches, makes its way to the x-axis. So this one's kind of interesting. The number of hours that have fallen depends on the number of inches that have accumulated in the rain gauge, right? But that's what it says. What are going to be the units of F inverse prime? Hours per inch. Now notice how I wrote F inverse prime. Does that look right? That looks like negative 11. The heck is that? So here's how you're going to write F inverse prime. F inverse, you got to put parentheses around it and then put prime. And we're going to study inverse functions in its own section later on. Well, you're just going to have to call it dy dx. You could do dx dy. Yeah, that's actually, you could do that, dx dy. But typically we rename our input x. So that's the only downside to that. All right, so what are the units of 10 in this case? Inches, right? So when 10 inches of rain have had fallen, okay, at that instant, right? Like someone's out in their yard and they're looking at the rain gauge and right there on these 10 inches. That's a lot of rain. What are the units of 16? Hours. 16 hours had elapsed. Wow, 16 hours, 10 inches of rain? What did Harvey just send Houston? Yeah, they'd be like, man, we'll welcome that. 10 inches in 16 hours, we'll take that, please. Yeah. So we don't usually keep time like this, right? We usually have a watch on. We're like, oh, it's been an hour. I'm going to go check the rain gauge. We don't usually walk around with a rain gauge on our wrist and saying, oh, I've collected 2 inches. I wonder how many hours have passed, right? Does Apple make like an iWatch that's a rain gauge, F prime of 8. What are the units of 8? We're back to F and F prime, so it's back to hours. So at 8 a.m. or at T equals 8 hours after midnight, whatever you want to say, comma, now we're talking about the rate of change of F. So what are we measuring on the y-axis for F? Yeah, we're measuring inches. We're measuring rain that has fallen since midnight. That's what we're measuring on the y-axis. Rain that has fallen since midnight. So this is the rate of change. So the amount of rain that have had fallen since midnight is whating? Increasing or decreasing? Is increasing by, I put increasing without the G. Yeah, it's increasing, y'all, by 0.4, what per what? Inches, and then we write it out, PER, hour. You always write the words out for the derivative of the function that came before, PER, the units of the independent variable. So you could actually refine that too. The amount of rain that has fallen since midnight, you can kind of call that collective rainfall, right? At 8 a.m., the amount of, or the rainfall is increasing by 0.4 inches per hour. All right, now here's a wacky one, right? F inverse prime of 5. What does 5 represent? It's F inverse, so it's inches, yeah. So when 5 inches has fallen, comma, what are we measuring on the y-axis on F inverse? Yeah, time. When 5 inches have fallen, time is increasing, right? Time is increasing by 2 hours per inch. Now that one right there is the guy walking around with a rain gauge on his wrist, right? Time is increasing. Good thing that was a positive number, right? Because if that were a negative number, time would be what? Decreasing. You could probably refine it by saying when 5 inches of rain has fallen, time is passing by 2 hours per inch, or is elapsing by 2 hours per inch.
And Vice President is Sydney Keogh. Voting for homecoming court will be next week, Monday
All right.
and Tuesday.
The next thing
Also, reminder for
that we're doing,
officers, there will be a meeting this afternoon. Right
we have like 4 minutes.
If you can't be there, please let Ms. Trollinger know.
Just want to point this out to you.
And there will also be a meeting.
Example 4. Go ahead and start reading example 4.
323.
It's kind of interesting.
Interested in competing in the UIL academics. Thank you.
Sometimes calculus works its way into politics. In 1972, Richard Nixon, as Hugo Rossi pointed out in 1996, it was the first time that he could find where a president was using the third derivative to advance his case for re-election. Okay? Why was that the third derivative? Well, here's what Nixon said. Nixon was announcing the economic situation to the general public, and he said that the rate of increase of inflation was decreasing. Right? The rate of increase of inflation was decreasing. So, part A, laugh out loud. Nixon. What did actually Nixon mean? Did Nixon know what he was saying? I mean, there's like words that mean something mathematically that are very different from what they mean in the lay community, right, to the lay person. And this, if you analyze it, the rate of increase of inflation was decreasing. That sounds like a good thing, right? Oh, okay. Well, if inflation is going up but decreasing, I guess I'll vote for Richard Nixon, right? Because that's what we want. First of all, why is it the third derivative? Yeah, anytime you say the word increase or decrease, there's one derivative. And so it was increasing at a decreasing rate. So he said it twice, so that's the second derivative. But the first derivative comes from the word inflation, because inflation is the rate of change of one's purchasing power, right? And so inflation, like time, usually just travels in one direction. It doesn't increase or decrease, right? Inflation happens. Purchasing power usually does what? You want to hedge inflation the best you can. But inflation, when it happens, your purchasing power is decreasing. Okay? So the decreasing purchasing power is increasing, which means your purchasing power is becoming more and more or less and less powerful, but at a slower and slower rate. So if inflation is going to increase, I'm glad we're doing it at a decreasing rate, okay, and not an increasing rate. So there you go, winning Nixon, of course, got reelected. The rest of the story, because of calculus, and then Watergate happened, and he resigned. So have a great rest of the day.